Hi, I'm James Marengo, editor of Interference Technology Magazine. I hope you're enjoying EMC Live Fundamentals 2021. Our next session is a product demo presented by Dale Hawk, Applications Engineer at AR/RF Microwave Instrumentation. In this product demonstration, EMCware 6.0 will be presented. From populating the equipment list, selecting and setting up a test, to executing a test and report generation, with additional focus given to multi-tone capability, demonstrating setup and execution of a multi-tone test. I encourage everyone to use the Q&A box below to ask Dale questions during the session. Once he concludes presenting, we'll answer as many as we can. Without wasting any more time, Dale, please take it away.
EMCware is a comprehensive EMC test software package for radiated susceptibility, conducted immunity, radiated emissions, and conducted emissions. This powerful software package contains predefined test profiles for hundreds of the most commonly performed test standards and test levels to allow the test engineer to quickly set up and execute EMC testing. With the recently released EMC 6.0, multi-tone immunity testing is now available. In this product demo, EMCware will be presented from populating the equipment list, selecting and setting up a test, to executing a test and report generation. Additional focus will be given to the multi-tone capability, demonstrating setup and execution of multi-tone. Exactly what is multi-tone testing? Rather than testing a single frequency during every dwell period, multiple signals, also referred to as multi-tones, are generated to simultaneously test across a frequency band. While simple in concept, the actual software and hardware implementation has always been problematic. Simultaneously controlling multiple signal sources and properly combining their output signals in a repeatable fashion is vital for accurately setting EMC test levels. AR has been a pioneer in this endeavor. With the release of EMC 6.0, multiple tones injected into an amplifier can be corrected. When more than one tone is injected into an amplifier, intermodulation products will be exhibited as shown here. EMCware controls the maximum allowable intermod products and harmonics, thus assuring these nonlinear signals do not impact the desired test level. The ability to measure each discrete frequency component requires a frequency-selective receiver. What is the advantage of using multi-tone testing? Put simply, a huge reduction in test time. Notice that with the application of just one additional tone, test time can be reduced by as much as 50%. This translates into a significant cost reduction and higher throughput. How much can you save? We have a return on investment calculator shown here. If we factor in the time it takes to test one tone over 6 EUT surfaces and 2 polarities, with a 3-second dwell time, that's 435 test points for a frequency range of 80 MHz to 1 GHz at 1% step size. That's 4 hours and 21 minutes of test time. Factoring in a relative cost of technicians and engineering, overhead costs, we can reference a cost per week or per year for testing. Now let's increase our tones to 2. Notice that test time is reduced by 50%. This translates into a 50% reduction in overhead costs. The payback period, based on a fixed amount, can be less than a year and a half, saving you labor that pays dividends year after year. Is multi-tone testing allowed by EMC test standards? Historically, they have not placed restrictions on using more than one tone, as long as those multiple tones do not create intermod products or harmonics that would violate the desired test level. Specifically, IEC 61000-4-3 Edition 4 has cited multi-tone testing as a standard of test. What should be considered when choosing multi-tone testing? Consider Annex I.4 of IEC 61000-4-3. The level setting and calibration should initially be done in single tone. When using multi-tones, it must be assured that harmonics and intermod levels do not impact the test level. When an equipment failure is noted, always drop back to single tone to make sure that there is not an overtest situation. What components make up a multi-tone system? Here we have a system capable of testing to IEC 61000-4-3 10 volt per meter requirement. It's composed of a field monitor, a spectrum analyzer used for power reference and intermod and harmonic levels, 2 signal generators phase locked and isolated so as not to interfere with each other, and amplifiers and antennas paired to cover the 80 MHz to 6 GHz range. Let's look at an overview of the EMCware software. As we said, this software will do conducted, radiated, emissions, and susceptibility. Multiple standards are already predefined and covered. We have internal functionality to allow security functions so that you can safeguard your test information. Also, many interfaces to the instruments and the way you do your test so that you can effectively streamline and test your equipment effectively. Things like amplifier warm-up to protect your equipment are all built in. Another very useful function is a timing window. Many instruments require specialized delay in order to respond with data from their measurements. All these things can be set, but we recommend the default setting. Your EUT may also be monitored, either manually or automated. The equipment list icon is where you can store all the equipment you have in your test setup. I've pre-populated with some default instruments for making radiated susceptibility measurements. All the instruments are available for you to enter: signal generators, amplifiers, antennas, and so forth. You can enter all your new equipment very easily: the model number, serial numbers, descriptions, and there's a calibration function if you want to be prompted when calibration is due. We have drivers for many instruments already loaded, both older and newer, across different manufacturers. The System Controller tab is used for switching between the signal generator and amplifiers and antennas if you have an antenna switch enabled. This is useful for broadband measurements. We're ready to set up a test configuration. The test setup icon is here. We have preloaded the IEC 61000-4-3 test. There's a signal routing tab and an EUT monitoring tab that we'll cover in a little bit. As we've said, there are many predefined tests already entered into the software. This is used to get you started very quickly. Here is the default setting for that level 3 IEC test. You can set up the way the signal generator is generating power, the tolerances, and frequency ranges and step sizes, and we'll add an extra step point here and extend this to 6 gigahertz. Notice you have the ability to set the test level, and dwell times, and modulation for each frequency range. Since we created a 6 gigahertz test profile, it's going to require a change in antennas and amplifiers. The system is set up to put in breakpoints. 1 gigahertz is the usual breakpoint for this band, and we're going to extend it now from 1 gigahertz to 6 gigahertz. To do this, we need to enter the equipment as shown in the block diagram for the system to run. Signal generators, combiner when we're doing multi-tone, the amplifier for this particular band, we'll also set up an antenna, and a power measurement instrument, which is our spectrum analyzer, as we've mentioned. So now we have a breakpoint starting from 1 gigahertz going to 6 gigahertz using a different amplifier and antenna pair. That's done in the signal routing tab. We can also put in a user message to tell the user at this point, if it's not automated, to switch antennas. The EUT monitoring tab will allow you to enter an automated EUT monitor or manual controls. Now we're ready to do a calibration on that test profile we set up. We'll do a field calibration. You'll notice there's a window that will graph our reference forward power and a window that will graph our targeted field level. We set it up for 10 volts. We'll do a single point calibration point for the sake of time and restrict it to vertical only. Pertinent information can be entered and will be seen on the report. Again, a single point of calibration, and we can skip warm-up time for the sake of this demonstration. So you see the system will now run. You can read your information that's on the signal generator and power output. It's always good to monitor, and it's also being graphed here. The level again is 18 volts because we want to test it at the higher AM modulation point. Then we're going to test linearity to make sure that at that 18 volt CW calibration point, we weren't in saturation. Dropping power back by 5 dB and noting that the change is still at 5.1 dB and it was not in saturation. This is a good way to give you an idea of how much overhead you have when you're doing two-tone tests. And here's our breakpoint at 6 gigahertz. Switching antennas. Skipping through that quickly, and it'll run through very quickly. Again, a shortened profile for demonstration purposes. I have this set to 10% step size and a shortened frequency range. This configuration shows that you have plenty of margin to use two-tone, an additional 3 dB of power, so we're not anywhere near compression. And that's it. That completes a single tone calibration where everything passed. Now that we've completed a single tone calibration, we can run multi-tone calibration. It needs single tone in order to reference the test levels for each multiple tones. It'll run through the same basic sequence. We have options for how the test is run, how the tones are applied, and the harmonic levels and intermod levels that you want to reference your limits to. These are default to the IEC standard. Now we need to choose that calibration file that we just did. Because the system keeps you from making mistakes. If you didn't do it horizontal, you notice the software will keep you from trying to run a test you didn't have a calibration for. We'll also skip high frequency for the sake of time for this multi-tone calibration check. Skipping the amplifier warm-up. We're now going to check with multiple tones, or in this case, two tones. See the two tones that are represented here, playing back the reference power from the single tones. Power, of course, is total power is 3 dB higher. What you'll notice on the right-hand side, we have a linearity window and a harmonic window. We're still within spec with this demonstration setup. Harmonics are also in spec. Running a little slower because each tone is assured and measured individually to make sure that they're not interfering with each other. But once the calibration is done and we've passed, that completes your multi-tone test calibration. We can save that as a multi-tone cal file. Now we're ready to run a multi-tone test. The data seen here was from a previous run, so we can ignore that. Notice the file was incomplete. We get that warning because for demonstration we skipped the 1 to 6 GHz calibration. We're doing substitution multi-tone. You can set up your turntable position so that if you had one in the system, you can set a priority of which you wanted to do the turntable first and then the polarity, or vice versa. We're only doing 1 point, so we'll have that fixed. You also have options to set up discrete frequencies. Maybe you're troubleshooting and doing mitigation. We need to choose the multi-tone calibration we had done. Again, we have to skip high frequency since we did not calibrate that. Only doing low frequency. A repeat again of all the pertinent information. We're only doing one position, skipping the warm-up time, and we're replaying our tone power levels. The trace shows the measured sum powers. which is of course going to meet 10 volts, and we know we had AM modulation, so the peak voltage is 18 volts. That, because of our demo setup, shortened setup, this went very quickly. And we can save that test profile that we just run and all the data. So that very quickly performed a multi-tone shortened test run. We're ready to run a report. Moving on to our report generation tab, we can choose what report we want: field calibration, multi-tone cal. Let's look at the test report. We'll pick the one we just ran. We have some pertinent information entered for that file that we just selected. We can choose to output that in MS Word, PDF, or Excel. We're going to run a Word document. We'll generate the report. This, depending on your computer and how much data manipulation and crunching that needs to take place, might take a few minutes. We had a relatively short data run, so this should go fairly quickly. Now, the report is done. Here it is in the Word format. Again, all the pertinent information that was entered, the test files, all these things, the field level in a graphical format is shown, the forward power level, both single and multiple tones, and a tabular list of all the pertinent data and information. All these can be edited. You also have the option within the report generation file to pick and choose what information you want to put in this report. But since it's in Word, you're free to edit it as your standards and test dictates allow. That completes our report generation. As you can see, the benefit of multi-tone testing is significant, and with EMCware, this testing is fully automated. AR RF microwave has been on the forefront of EMC multi-tone methodology. The adoption of multi-tone into IEC 61004-3 is evidence that this represents the state-of-the-art of EMC testing technology. Please contact AR Applications for a system that meets your particular unique requirements.
Thank you so much, Dale, for your product demonstration. I really appreciate it. We have a very active Q&A panel here, so we can get as many questions in as possible. I'm just going to start right into it. Dale, are you ready?
Sure, let's get right to it.
Okay. First question. Is the term tone synonymous with harmonic frequencies, which seems to be what is displayed in the spectrum analyzer screen in the slide?
So when we're referring to tones, we're referring to the specific frequencies of test. Two tones, there's two frequencies being tested. And because there are two tones, going through an amplifier is going to cause intermodulation products. These aren't specifically harmonics, but certainly the harmonics will also be affected and measured as well.
Great. Next question. So would this multi-tone testing reveal intermodulation projects, conducted noises caused by RF fields at different frequencies, etc.?
Again, the system does check those intermod products, making sure the levels don't exceed specification. The goal of the software is to make sure that the test level is not impacted to overstress your device.
Great. This next question is kind of multi-part, so just bear with me. If you need any clarification, I'll try my best. But it starts off with, are there different licensing levels? For example, my application is for in-house pre-compliance testing only for conducted and radiated emissions. No muting tested at my design. We do not sell our testing services. So it's quite difficult to cost justify expensive software that is not continuously used. Can you approximate or just discuss any licensing levels or licensing options associated with this product?
So unlike other expensive software packages, EMCware does not nickel and dime you for every testing you're going to be doing. It's fully open for all RI, CI, RE, and CE testing methods.
Great. All right. Next question. Could you please explain how to perform the multi-tone test according to MIL standard 461G standard procedures?
We don't have it. It's not specifically in that standard as yet, but it's certainly something that the board is looking at.
All right. And we have time for one more question here. What is the hardware interface between the various equipments, e.g. single generator, spectrum analyzer, and software on a laptop?
So it's very much dependent on the equipment used, but the system and the software is equipped to handle all interfaces, Ethernet, USB, GPIB, even RS-232, should you have that need.
Great. I just want to let everybody know that if you ask the question, it will be answered after the event. Also, this presentation and all presentations will be available on demand after the event concludes. Once again, I want to thank Dale and AR for their time. And I also want to encourage everybody to attend the rest of EMC Live Fundamentals. AR has a technical webinar tomorrow that it's going to be very good. And just once again, thank you, Dale. Thank you, everybody, for attending this session. And we'll see you at the next one. Have a good day.
Thank you, James. Thank you, everyone.